Alrighty, so today we're going to be looking at our intro unit, notes number 4, and we're going to be graphing using a table. So we're going to be making input and output tables. I'm either making those by hand or with a calculator and graphing those. So today I will be able to graph a function, that's an A, using an input output table. Alrighty, so notice that I've mentioned that we are only going to be graphing functions. For our unit, there are 3 types of functions that we're really going to be focusing on, and those are linear, quadratic, and exponential. Those are the 3 functions we really focus on in Algebra 1A as well, so those should be kind of familiar. So just a quick reminder, if we're talking about a linear function, so draw my coordinate grid. If we're talking about a linear function, that's going to be a straight line. It can be any straight line, but as long as it's straight line. Okay, so you only have to draw one. But just a sketch of what does a linear function look like? Nice straight line. And we're talking about an exponent. Remember, it has an exponent of a 1. So, for example, it could be y is equal to x. Okay, because that has an exponent of a 1. This second type of function we're going to be focusing on is quadratic. Now, if I were to draw a picture of a quadratic function, you're going to see something that looks like this. That's a parabola, so just remember that that's a parabola. Anytime we're talking about a parabola, that's going to be a quadratic function. And what type of exponents do quadratic functions have? Their largest exponent is a 2. So for example, y equals x squared. Okay, so we have a 1 and a 2 for our exponents. Now our last type of function is our exponential functions. Draw my coordinate grid. An exponential function is going to look like that. It's got that nice curve to it. Remember, it's never going to hit the x-axis unless it's shifted up or down, but right now we're just looking at when it's not going to hit the x-axis. And what type of exponents do exponential functions have? They have x's for exponents. They have x's. All right, so we're going to go through and graph one of each of these types of functions. Okay, so we can just kind of get familiar with what they look like again. So looking at the first one, it says given the following functions fill in the input and output tables and graph. So we have f of x equals negative x squared plus 1. Okay, so we're going to fill out our input and output table. Remember, the table is always going to have negative 2, negative 1, 0, 1, and 2. Looking at this function, you can either use your calculator or you can draw out the input and output table, show all the work for plugging those numbers in. We're going to show all the work in this video, okay? But if you want to use your calculator, you are more than welcome to it. So we're going to start by plugging in the negative 2 in for the x. So our first one is going to be f of negative 2 equals negative, and then in parentheses, we're plugging in that negative 2. Negative 2 squared plus 1. And then we're going to simplify. So I'll have a negative. Negative 2 squared gives me 4 plus 1. Negative 4 plus 1 gives me negative 3. So my first output is a negative 3. We're going to do the same thing, but with the negative 1. So I'll have f of negative 1 equals negative 1 squared plus 1. And simplify, we'll have that bring down that negative. And then negative 1 squared gives me 1 plus 1, which gives me 0. So my second output is a 0. Okay, next we're going to plug in the 0. So now I'll have f of 0 equals negative, and then 0 squared plus 1. 0 squared gives me 0, plus 1 gives me 1. So my output's going to be a 1. And then guys, the great thing with parabolas is they're symmetrical. So then we know that it's also going to be a 0 and a negative 3. So we're going to go ahead and plot in our points. So our first one was -2, -3, plot a point. Our second one, let's check our table, was -1, 0. Our third one was 0, 1, 1, 0, and then 2, -3. And we'll connect our points. And then we're good to go. So remember, since this had an exponent of a 2 and it makes a parabola, this was quadratic. So everybody label it quadratic. All right. Our next one we have is g of x equals 3x minus 2. Okay, we're going to make our input and output table. So -2, -1, 0, 1, and 2. And we're just going to plug all these in for x. So we'll have g of -2 equals 3 times -2 minus 2. 3 times -2 gives me -6 minus 2. That's an ugly 2. There we go. -6 minus 2 gives me -8. So our output's going to be -8. We're going to keep doing the same thing over and over. So next we're going to plug in that -1 for the x. So we'll have g of -1 equals 3, and instead of an x, it becomes a -1 minus 2. 3 times -1 gives me -3, minus 2 gives me -5. So this output's going to be -5. Same thing now with a 0. So I'll have g of 0 equals 3 times 0. Oops, it's an ugly 3, isn't it, guys? 3 times 0 minus 2. Well, 3 times 0 just goes away, gives me 0. Minus 2 gives me -2. And I'm just going to keep going. Isn't this so much fun? So much fun. So we're going to plug in the 1. So now we have g of 1 equals 3 times 1 minus 2. Well, 3 times 1 gives me 3 minus 2, which gives me 1. So I have a 1 for an output. I'm going to do this one last time, because it's got to stop eventually. Actually, it keeps going on and on forever because it's a linear function. That means it keeps going on and on forever. That's just so cool, guys. So g of 2 equals 3, and instead of times x, it becomes times 2 minus 2. Well, 3 times 2 gives me 6, minus 2 gives me 4. So now that we have all of our outputs, we're going to plot those. So I'll have -2, -8, way down here. And then we had -1, -5. And then we had 0, I think -2. Yep, 0, -2. Then we had 1, 1. And then 2, 4. I'm going to connect all of our nice points. And then we're good. All right. So we've got 2 awesome graphs. This one's a nice straight line, so we know that it's going to be linear. All right, moving on to the next one. So we got one on the back. Okay. We have g of x equals 1/2 to the x. So we're going to go ahead and make our input and output table. -2, -1, 0, 1, and 2. Okay, we're going to plug all these in. I hope you remember your exponent rules from way back like last October. It's been a while, but we're going to see if we remember. So we're going to have g of -2 equals 1/2 to the -2. So what happens when it's negative is that means it flips. So it becomes 2 squared and the negative goes away, which is 4. So that negative means everything has to switch. So it becomes 2 over 1. And then it just becomes 2 squared, which will give me 4. We will practice that a lot, don't worry. The next one we're going to plug in is that -1. So I'll have g of -1 equals 1/2 to the -1. That negative is going to make everything flip. So it becomes 2 to the first, which is just 2. Now plug in the 0. So I'll have g to the 0, or g of 0 equals 1/2 to the 0. And everything to the 0th power is always something. And hopefully, maybe you're going to remember that everything to the 0th power is always 1. Anything to the 0th power is always going to be 1. If you didn't remember that, that's fine. We are going to keep practicing. And then next, we're going to plug in the 1. We'll have g of 1 equals 1/2 to the first. Well, anything to the first power is just itself, so that's going to be 1/2. And then last but not least, we'll have g of 2, which is 1/2 squared. Well, that means we're going to square the top and the bottom, so I'll get 1/4, because 2 squared gives me 4, so 1/4. Alrighty, from here we're going to graph all of our wonderful points. So I'll have -2, 4, -1, 2, 0, 1, 1, 1/2, and 2 and 1/4. Graph that, connect all those points. Remember, it's never going to cross that x-axis. It's going to get really, really close, but never actually cross that x-axis. And that's going to be it. All right, so the last 3, we're just rearranging in a slope-intercept form. Remember, that's going to be y equals mx plus b. We're really just getting the y by itself. So the goal is to get the y alone. So we're going to start by getting rid of the 2x. It's positive, so we're going to subtract the 2x over. Those will cancel. I'll have -3y is equal to. These do not combine. These are not like terms, so I can't combine them. So it's just going to be -2x plus 6. From here, we have to get rid of this -3. So to do that, we're going to divide out the -3. And that means we have to divide everything by the -3. That cancels out. I have a y is equal to. These two negatives cancel each other out, so I'll have 2/3 x. 6 divided by -3 gives me -2. Looking at number 5 is a little bit different. We still want to get the y by itself, but we have this little exponent we have to deal with. Anytime we see an exponent, the very first thing we have to do is distribute. So I'll have y plus 5 is equal to -2 times x gives me -2x. -2 times a -8 gives me positive 16. From here, we need to subtract the 5. We'll have y is equal to -2x. 16 minus 5 gives me plus 11. All right, and then the last one. We have 5x plus 2y equals 15. We want to get the x all by itself. So, or not the x, wow. We want to get the y all by itself, so I'm going to subtract the x over. That cancels out, so I'll have 2y is equal to, I can't combine those because they're not like terms, so I just have -5x plus 15. Divide out the 2. Now I have y is equal to, -5 divided by 2 gives me a fraction, so we're just going to leave it as -5 over 2x. 15 divided by 2 also gives me a fraction, so I'm just going to have plus 15 over 2. All right, if you have any questions, please let me know. If not, you can move on to your assignment.